and it would favor the reverse reaction. So when temperature or heat is increased, the reaction will shift away from the reaction side containing the heat. So this is the same exact rule that we used for concentration. So this would be in the endothermic direction. When temperature or heat is decreased, the reaction will shift towards the reaction side containing the heat, and this would be in the exothermic direction. Let's look at a couple of examples. In example 1, right away, I can see that heat is on the right side, so this is an exothermic reaction. And if we add heat, so if I increase the heat, that means that the shift is going to be to the left, which means that we're going to be making more NH3 and O2. So if I'm increasing the production of NH3 and O2, favoring the reverse reaction, that means that NO, the concentration of NO and the concentration of H2O have to be decreasing because they will be colliding in order to make the NH3 and the O2. It says if we add heat, which concentrations will increase? Well, we just discussed that that would be the NH3 because it's favoring the reverse reaction, and we're going to increase the production of the O2 and the NH3. Let's look at another example. In this reaction, our energy is on the left side of the reaction, so this is an endothermic reaction. And if we remove heat, so if I decrease heat, remember that the decrease, we go toward the decrease, so the reaction will shift to the left. So this is shift left. We're favoring the reverse reaction, and what's going to decrease would be the CH4 concentration and the O2 concentration because they will be colliding more in order to make more CO2 and H2O. And then which will increase? Well, we just said the CO2 and the H2O would be increasing because it's favoring the reverse reaction. So that's temperature. Let's look at pressure. Pressure is one that you have to memorize. The rules are different. Usually when we increase stress, the shift is away from the stress. It's the same for pressure, but we think of it in different terms. We have to look at the moles of gas in the equation. So as the initial stress, recall that pressure affects gases only. So we have to have a gas system. So every other state, solid, liquid, aqueous, in the reaction is unaffected for this type of stress. If we increase the pressure, the reaction is going to shift to the side with the least number of gas molecules, or least number of moles of gas. If we decrease the pressure, the reaction is going to shift to the side with the most number of gas molecules, or the greater number of moles of gas. This is really important. If the reaction contains no gas molecules, or if the reaction has the same number of gas molecules on each side, then there is no effect and no shift. Let's take a look at a couple of examples so this makes sense to you. Here I have gas and here I have aqueous. If we increase the pressure, the concentrations of which species will increase? Well, if we increase the pressure, it's going to shift to the side with the least number of moles of gas. What will happen is it's going to shift this way. We're going to force the CO2 gas into the CO2 liquid. So the concentration of CO2 aqueous will increase. If we increase the pressure, the concentration of the CO2 gas will decrease. If we decrease the pressure, So if I'm decreasing the pressure, I'm essentially increasing the volume, which is going to allow the gas molecules to come out of solution. It's just like opening a bottle of soda. When I open that bottle of soda, I'm decreasing the pressure, so you hear that shh, and the CO2 gas comes out of solution. So we're going to increase the CO2 gas. It's going to go into the atmosphere, and we will decrease the CO2 aqueous. And in the last example, if we increase the pressure, in which direction will the equilibrium shift? So we're going to count the moles on each side. So I have 1N2 and 3H2 is a total of 4 versus 2 here. So if I increase the pressure, it shifts to the side with the least number of moles. It's going to shift right. So it favors the forward reaction. If we increase the pressure, the concentration of which species will increase initially? Well, if I increase the pressure and it shifts right, then the concentration of NH3 gas is going to increase initially. If we decrease the pressure, so what species will decrease initially would be the NH3, because it's shifting left, so it will be breaking down and forming more N2 and H2. And if we decrease, as we just said, the N2 concentration and the H2 concentration would increase because it's favoring the reverse reaction. Okay, that's it for today. Tomorrow will be lesson 6.